Okay, this is simplifying expressions with rational exponents. Basically, when a number raised to the power of 1 to the n is equal to the nth root of that number. Basically, what they're doing is, if you have b to the 1/nth power, you know that n is the index. So technically, we can rewrite it like this, b to the first power. All right, so the index is n, the 1 is the power. So that we've already discussed this in class today. So what I'm going to do is I'm going to erase this, what I just wrote. Oh, here we go. Let me erase that. All right, let me pull this up a little bit. Now, I just want to go over some of the examples here, okay? Let me go right here. Right here. Now, I want you to notice something. This is b to the 1/2 power. That means there's an index of 2 there, so that's the square root of b. All right? An example of that is when I have 25 to the 1/2 power, that's the same as saying the square root of 25. The square root of 25 is 5. Now, if I have it to the 1/3 power, that means I'm going to take the cube root. That's where that little 3 is in the index right there. So if I have 64 to the 1/3 power, that means I'm going to take the cube root of 64. Well, if you recall, when you have if I'm looking for the cube root of 64, that's saying what number multiplied by itself 3 times gives me 64. Well, I know that if it's 2 times 2 times 2, that's going to equal 8. Well, that's not what I want. And if it's 3 times 3 times 3, that's going to give me 27. Well, let's try 4 times 4 times 4. I know that 4 times 4 is 16. And if I do 16 times 4, that's going to give me 64. So the cube root of 64 is 4. All right? Now, let me go ahead and erase that so I can get that out of the way. So I'm going to erase this. There we go. Now, what I want to do is, if you look at this one right here, this is the 4th root. So it's the 4th root of b. Well, we're doing the same thing right here. It's the 4th root of 81. So the 4th root of 81 is 3. That means 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. And 9 times 9 is 81. That's why the 4th root of 81 is 3. And you're going to have to get really good at knowing your square roots, your cubed roots, and your 4th roots, and a couple of your 5th roots. Like the 5th root of 32 is 2. Those are some things that you need to know. All right? All right. Using properties with rational exponents. You can use properties of exponents to simplify expressions. Okay, we're going to go over some of these properties real quick. The product of powers property. The product of powers means when you have a to the n power times a to the nth power, you get a times n plus n. So notice, this right here, when you're multiplying like bases, you're going to add the exponents. Quotient of properties. When you are dividing like bases, you will subtract the exponents. Let me get a different color. Okay, power of a product property. When you have a times b, notice that a times b is inside the parenthesis, but we're taking it to the nth power. That means I can distribute that power to both the a and the b. All right? Now, when I have a power of a quotient property, quotient means division, when you're going to divide. So if I'm dividing, I'm still going to distribute that n to both the a and the b. Now, in this case, they're saying b cannot be 0 because if you have a 0 in the denominator, that makes it it's not a good number, and I'll talk about that later. All right, power of a power property. If you have a power to a power, just like we talked about earlier, we're going to multiply the power. So you get a times m times n, a to the power of mn. And then when you have a negative exponent, that makes it turn into the reciprocal. The a becomes positive because it's unhappy now. When it goes down to the bottom, the n becomes happy. It's a reciprocal. All right, so here are some of the examples. Again, if you have 2 to the power of 2 times 2 to the power of 3, you're simply going to add the exponents. 2 plus 3 is 5. That's like saying 2 times 2 times 2 times 2 times 2. That means you have 5 2's. All right? In fact, let me go ahead and I'm going to do this right here. I'm going to bring this over here so I can show you some examples. All right? So now, let me go ahead and put this in blue. So basically, if I have 2 to the 5th power, that's just saying 2 times 2 times 2 times 2 times 2. That's 2 squared. That's 2 to the third power. That's where you get 2 to the fifth power. All right, now, what happens when you have, when it's divided? Well, if you have 5 2's on top over 3 2's on the bottom, simply you eliminate those and you have 2 times 2 on top, which means 2 to the fourth power on top, which is just 4. And that's where we get that right there. All right, the next one. Let me go ahead and erase some of these so I can have some space here. Okay, so I'm going to erase all that. Let me erase these numbers here. All right, now I have more space. All right, now notice, when I distribute this one, it distributes to the 2 and the 3. That means I'm going to have 2 times 2, and then 2 times 2 times 2. That means I have 2 to the fifth, 2 to the fourth power that's 4. 2 to the third power is 8. I'm sorry, I take that back. This is 3 to the second power, not 2. Let me go ahead and eliminate that. I was a little wrong with that, premature there. So basically what happens is when you distribute this, you get 2 times 2, which is 4. And then when you have 3 to the second power, it's 3 times 3, which is 9. And then 4 times 9 is 36. That's where they get 36 from. So on and so forth. All right, on this next slide, what we're going to do is we're going to take those properties. And like if I have 125 to the 2/3 power, we kind of cover this in class. Here's my index. Here's my power. Well, I'm going to do the cube root of 125, and then I'm going to square it. Well, you've got to notice, since it's ending in 5, the answer is going to be 5 times 5 times 5. So the cube root of 125 is simply 5. So when I replace that, let me go ahead and erase that real quick. Let me erase this right here. Okay. So what I end up getting, didn't do it. Let me erase that right there. So basically, as you notice, let me kind of blow this up a little bit. Okay. Now, what they did was they took the 2 right here from the power, and they moved it to the outside. They took the 1/3, and they're going to take the cube root of 125, which is 5, and then they're going to square it. All right, so 5 squared is 25. Okay, now we're going to look at this next one. We're going to look at 81 to the 3/4 power. Okay, so what they're going to do is they're going to take 81. That's basically the 4th root of 81, and then we're going to cube it. So remember, 81, the 4th power of 81 is 3, because it's 3 times 3 times 3 times 3. And then we're going to, since that the 4th root of 81 is 3, then we're going to cube it. That's going to be 27. So you can see in this how they kind of use the property, and I just kind of did a shortcut. On this one, what they did was 64 to the 3/2 power. Notice what they did was they split it up into 1/2 and 3. So they took the square root of 64 right here, which is 8, and then they're going to cube it. So the square root of 64 is 8. All right, and then 8 to the 3rd power is 512. That's just kind of, they use the power of a property. They're kind of going about it the long way. The approximate number of calories C that an animal needs each day is given by C is equal to 72 times M to the power of 3/4, where M is the animal's mass in kilograms. Find the number of calories that each animal needs daily. I want you to notice that they wrote down the equation. Then they said the Siberian tiger with a mass of 256. Well, what they ended up doing is they substituted that 256 in for the M. All right, and that's where they got that. So they take 256 to the power of 3/4, and they changed it to the 4th power right here. They get the 4th power of 256, which is 4, and then they're going to cube it. And then eventually they're going to multiply it by 72, and they get 4,608. That's kind of a higher level. That's where we want to be. I want you to get to this level to where you can do a word problem like that. Now finally, the last problem, an Asian elephant with a mass. So we're going to use the same problem. So instead of the 200 and something, we're going to substitute the 4,096 in for M, because that's the mass of the animal. So again, we're going to do the 4th root of 4,096. Now I would probably let you use your calculator on this, which would be 8. And then we're going to take that 8 to the third power, which would be 8 times 8 times 8, which is 512. That's that part right there. And then you do 72 times 512, which is 36,000. So an elephant needs 36,864 calories per day.